Okay, today we're going to look at quadratic functions. So our learning intentions is to understand the skills to sketch quadratic functions and the awareness of some of the key features. So some of the success criteria is we should be able to identify what makes a function a quadratic, understand key translations between algebraic equation and its graph, know what is meant by concavity and turning points, so maximum and minimum, able to calculate the axis of symmetry, and can calculate the roots or the x-intercepts. Okay. So what is a quadratic function? So a quadratic function has an equation in the form of y equals ax squared plus bx plus c, and where the highest degree or the power of x is 2. So you're looking at this highest degree here would be a 2. The graph of this function is called a parabola. That's from that Maths in Focus book, 3rd edition. So some examples of quadratics would include the basic y equals x squared. Would have y equals x squared plus a constant, like 2 or 3 or 4, or minus 2 or 3 or 4. That also includes y equals x minus, so for example, 2 all squared, or we can have y equals x minus, let's say, t, or plus t, it doesn't matter. So it could be any number. That would make a quadratic. You might get to see things like this, where you've got x plus or minus a, and x plus or minus b. Yeah, that will make another quadratic. You can even have things like this, x minus 2, or whatever constant. So they all make quadratics. We can use a table of values to calculate some coordinates for quadratics. For example, here we have f of x equals x squared, and we're just going to fill in the table. So wherever I see, I'm going to plug these values of x into this equation. So 0 squared, when x equals 0, 0 squared is 0, 1 squared is 1, 2 squared is 4, and then 3 squared is 9. And when I use my negatives, so negative 1 squared, so negative 1 times negative 1 is positive 1, because 2 negatives make a positive. And if I was to use a calculator, and I wanted negative 2, I would go negative 2 inside the brackets, and then I would square it to get 4. Okay. Just obviously make sure, because if you do this instead, so negative 2 squared, it's telling your calculator to square 2 first, which becomes 4, and then times it by negative 1. And that's why you get a negative solution, where it should be positive. So negative 3 squared is 9. Okay, so we've used the table of values to figure out x and y coordinates based on this quadratic function. It's really important to know how the quadratic appears as an equation and how it translates around the Cartesian plane. So once again, so we saw from the table of values, we have the basic quadratic, which is y equals x squared. And so that looks like this U shape. Here you saw that was 1, 1. This is x equals 2, goes up to 4, and then 3, and 9, and the same. Okay. If I have the basic function, y equals x squared, and I add a constant, let's say 2, what that means is that this parabola is translating vertically up the y-axis by 2 units. So I have x squared, and I'm shifting it or translating it 2 units. So it would look like that. Yeah, where you'd get 1 plus 2 is 3. And so that coordinate there would automatically become 1 and 3, and so forth. Okay. Obviously, the opposite occurs if you're going to have x squared minus a constant, right? Let's say 1 for this time. So it's just going to shift it down, or translate it down 1 unit. Yeah? So some notes. Okay, so if you have y equals x plus k, or x squared plus k, it translates the parabola vertically up the y-axis k units. Yeah. Now, obviously, if we have y equals x squared minus k, it will translate the parabola vertically down the y-axis k units. Okay. Now, if I have, so still staying with this y equals x squared, the basic parabola, if I have x, and I want to do minus 2 squared, yeah, basically what happens is that it will translate the parabola 2 units across, because remember, if this was 0, this needs to be 0, we want an x-intercept. So 2 minus 2 is 0, and so what happens is the parabola ends up going like this. Yeah. You think of it, if we expand that out, that's x squared minus 4x plus 4. That would be 0, 4. That's that one there. And so that's what happens. Okay, it will translate it to the right if you got a negative thing here. So, for example, if you had y equals x minus t all squared, the parabola will translate t units to the right on the x-axis. And the same thing would happen if we went opposite. So for example, let's say that was minus t. So if I had y equals x plus t all squared, well, to get this to be 0 so that it touches the x-axis, I need negative t. So negative t plus t would make 0, and I'd still have that. Yeah. So y equals x plus t all squared will translate the parabola t units to the left of the origin. Okay. Some other things that we need to know. All these rules would still apply, but if we had, say, for example, y equals negative x squared, what happens is it just becomes an upside down parabola. It flips over the x-axis, yeah? So it'll go like that. Okay, so so if we've got y equals negative x squared, it will flip the parabola. Upside down. So it'll have a sad face. And so that, for example, if we had y equals negative x squared plus 2, it would just basically still be that sad face shifted up two levels, and you'd get something like that. Same would go with shifting it left or right. Another thing to note, say for example we had y equals 4x squared, so it's still x squared, still a normal parabola, but we've got a multiplication of 4. That means that the parabola will change drastically and become narrower. So how fast it's kind of squared value will increase by 4 drastically, and so it will make the parabola much narrower. So when a of ax squared is greater than 1, the parabola will be narrow. And if a is less than 1, so obviously between 0 and 1, then the parabola will be wider. So saying it will have a wider dish, so it will go like that rather than a normal U shape. Okay, so it's important to know how we translate or how we move these parabolas around the Cartesian plane. Now also, if you had something like this, y equals x plus a x minus b, then what that means is that you'd have an x-intercept here at negative a and an x-intercept here at b. Would multiply those two, so that's this y-intercept of negative ab, and you'd have your parabola like that. Okay, so it's really important to know how to graph these quickly and to understand what it means as an equation as well as its graph. Okay, so concavity and turning points. So for parabola y equals ax squared plus bx plus c, if the coefficient of x squared, if the parabola is greater than 0, then the parabola is concave upwards and has a minimum turning point. So what you'd get is you'd get a parabola like that. Yeah, and so this shape has a minimum. Yeah, and if the a value is less than 0, so if it's negative, the parabola is concave down, so it would look like a sad face. And so what we also have, that's called a maximum turning point. So maximum turning point. Yeah, and that was a minimum turning point. Okay. Every parabola will have an axis of symmetry. It must happen. So whatever goes up must come down, and whatever goes down must come up. Okay. The axis will occur at the average of the x-intercepts, or when x equals negative b over 2a. And we're getting these values, negative b over 2a, from this form. So negative b over 2 lots of a. And to find the maximum minimum point where the axis of symmetry occurs, simply find the x and then plug it back into the original equation to find its y coordinates. So some important parts of a parabola. The parabola shape has a special properties. So for one of them is if a light is placed inside a parabola at a certain point, which is called the focus, then what happens is the lights hit the base of the parabola and translates it so that it creates parallel lines coming out of the parabola. Yeah. And that's how basically headlights work, satellite dishes work, and things like that. Yeah. So for here, I've got the focus. It hits or directs light or waves to the base. Yep. Even to the side, and it basically creates parallel lines transmitting out. Yeah. And we will look at that kind of special properties later on in the year. Okay, just introduction. So, given we're going to do a couple of examples. So, given the function x squared plus 2x, we're going to find x and y intercepts. So, the first thing I always do is I try to factorize it. So, this is factored form would be x plus 2. Okay, so the x-intercepts are basically the roots. So if this was 0, x would be -2, and this would have to be 0 in order for it to apply the null factor. And the y-intercept is basically this point, setting x to 0. 0 plus 0 is just 0. So I have something. I'll draw it over here. See if I've got some space. All right. So there's my x-axis, my y-axis. Okay. I have a y-intercept of 0. I have an x-intercept of -2. Let's just do 2 units. So that's -2. Okay. It's a positive parabola, so it's going to be a smiley face. So it's going to look something like that. We're going to find the axis of symmetry. So we've got two options. We're going to basically, the average of that. So the average of that was obviously -1. Yeah. Alternatively, if we used x equals -b over 2a, so -b would be -2 over 2 lots of 1, which is 2, which equals -1, which is the same. Yeah. So this is my axis of symmetry. Yeah. I want to find the turning point. So all I'm going to do is plug in when x equals -1. So we've got f -1, -1, -1 plus 2, -1, that becomes 1 to -1. So here is my turning point of -1, -1. As I said, it's a smiley face, so this becomes minimum turning point. Minimum turning point. Okay, so I have something that looks like that. It's just a sketch. Okay, is it even, odd, or neither? Well, from the graph we can see that it's definitely not even because it's not symmetrical around the y-axis. It's not odd because it's not symmetrical at the point from the origin. So it's going to be neither, but we can just test it. So f of -x, so is -x squared plus 2 lots of -x. That becomes x squared minus 2x, which is not f of x or -f of x. So this is neither. Okay, and let's talk about its domain and range. So the domain, yeah, this continues on forever and this continues on forever. So it will go, the domain will go from -infinity all the way to +infinity. I've got a very large number, I can plug it into there, I'll get a solution. The range, however, can go on forever, so that's okay, it can go to infinity, but it can only go to -1. Yeah, so it goes from -1 all the way to infinity. Okay. Example 2. Here we have this x squared minus 8x plus 7. I'm going to factorize it first. So that is x minus 7, x minus 1. As -7 times -1 makes +7, but -7 minus 1 makes -8. So the x-intercepts, I can tell from my factored form, are 7 and 1. And my y-intercept, I can tell by this form, is going to be +7. Okay, so if I sketch, so I have up here there's a 7, and I have 1, and I have 7 here. It should look something like that. So the axis of symmetry, let's use x equals minus b over 2a. Okay, so minus b is minus 8 over 2 lots of a, which is 1. So that becomes 8 over 2, which becomes 4. Yeah. And if we did the average, right, the average of 1 plus 7 is 8 over 2, which is still 4. Yeah, so I'm going to try to sketch this. I'll do it on this side. I'm going to have to do 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, and we said 1, 2, 3, 4. So here's my axis of symmetry happening. Okay. So let's find out where the minimum turning point is. And all I'm going to do is I'm going to plug in 4 back into the equation. So when x equals 4, we get 4 minus 7, 4 minus 1, 4 minus 7 is -3, 4 minus 1 is 3, so we get -9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So here is our turning point of 4, -9. As we said, it is a So it's a smiley face, whoops, happy parabola, positive parabola. Yeah. And so this becomes a local minimum. Yeah. So minimum turning point. Happens at 4, -9. Okay. Once again, from our graph, it's not symmetrical around the x-axis, the y-axis, so it's not even. It doesn't mirror out from the origin, so it's not odd. So it's going to be neither. Once again, we'll just test it. So we've got negative x squared minus 8 lots of negative x plus 7. So we get x squared plus 8x plus 7, which is not f of x. So this is neither. There's the graph. Let's talk about domain. So once again, the domain can go from infinity to negative infinity to infinity, and the range can only go from -9, so it includes -9, yeah, and goes all the way to infinity. No, if it includes, it's squared. If it can continue on, as you can always continue on from infinity plus 1, it's curly brackets. It's the curl. Okay. Example 3. We have y equals 2x squared minus 4x plus 6. So we've got negative 2 times 6 is negative 12. So negative 12, factors of negative 12 are negative 6 plus 2, and negative 6 plus 2 will give us negative 4. So plus 2x minus 6x, because that would times together makes negative 12, and positive negative 4. Okay, factor by grouping in pairs. Yeah. So take negative 2x, it becomes x minus 1 to become positive, minus 6x minus 1. So we got negative 2x minus 6 and x minus 1. Okay, so my x-intercept happens here at 1. And also if I apply the null factor of negative 2x minus 6 equals 0, I get negative 3, and my y-intercepts 0 times 0 is positive 6. So now I have 1, negative 3, positive 6. This coefficient is negative, so it's a sad face. It's upside down parabola. Okay, something like that. Axis of symmetry, we'll still use a formula x minus b over 2a. In this case, minus b says minus 4 over 2 lots of negative 2. That's 4. 4 equals negative 1. Okay, so the turning point will be somewhere there. I'll just test. So 3 plus 1 is, just double check. So minus negative 4 over 2 lots of negative 2 is negative 1. Yeah. Okay. Yeah. Okay. So the turning point would happen when f of negative 1 occurs. So we've got negative 2 lots, I'll just do it up here. So negative 2, negative 1 squared minus 4 lots of negative 1 plus 6. Negative 2 times 1 plus 4 plus 6. So 10 minus 2 is 8. Okay, so, and this is obviously going to be a maximum. So the maximum turning point is at negative 1 and 8. Alright, so let's see if we can draw it. So x and y. Okay, so we've got negative 3, 1, 2, 3. We've got 1, 6, 1, 2, 3, 4, 5, 6. And we have negative 1 and 8. So negative 1 and 8. Okay. And let's just draw them, click the dots, and we get something like that. Okay, once again, we can tell straight away it's not even or odd. We'll just test it once again. Okay, so negative 2 lots of negative x squared minus 4 lots of negative x plus 6. That becomes negative 2x squared plus 4x plus 6, which is not f of x. So function is neither. It's neither even or odd. Okay. Let's talk about domain and range. Okay, the domain obviously can take all x values, so it can go from negative infinity to infinity. And then the range can start at negative infinity. We've got plenty of values down here, but we'll only hit 8. Yep, as its y value. Just double checking that I use the y values for all of them. Yep, -9. And what? Yep. Okay. So looking back at our success criteria, we need to be able to identify what makes the function quadratic, which is obviously anything where the power is to the degree of 2, so x squared. Understand key translation. So a negative x squared makes a sad parabola, x squared plus k shifts it up, x squared minus k shifts it down, x minus k all squared shifts it to negative k, so we want a positive, it shifts it to the right, and obviously if we have a plus k, we'll shift it to the left. Know what's meant by concavity and turning points, like a maximum minimum. So if it's a smiley face, it has a minimum. If it's a sad face, it has a maximum. Calculate the axis of symmetry, so minus x equals minus b over 2a, and obviously calculate the roots. And to do that, obviously, our skills in factorization is important. Okay, and that's the end. Thank you.